Hello everyone. My name is Aljoy D. Magas. I am currently taking up Bachelor of Science in Information Technology at Isabella State University Chayan campus. Today, we will be discussing what is software testing and quality assurance. But, first, what is software testing? According to Myers 1979, testing is the process of executing a program or system with the intent of finding errors. Generally, testing refers to trial, experiment, or examination that is designed to determine the qualities or characteristics of someone or something. In short, it is finding out how well something works. Software testing is a method to check whether the actual software product matches expected requirements and to ensure that software product is defect-free. IT involves execution of software system components using manual or automated tools to evaluate one or more properties of interest. The purpose of software testing is to identify errors, gaps, or missing requirements in contrast to actual requirements. IT the process of evaluating and verifying that a software product or application does what it is supposed to do. Some prefer saying software testing definition as a white box and black box testing. Engineers perform all types of software testing activities to perform a software test process. It is used to test a feature by applying test data to get a result in order to compare actual and expected result. Expected result means it's from the client's point of view, while actual result is the outcome after a test execution. Who does testing? Software developers perform unit testing. Ideally, the same developer who writes the production code will create the unit test. This includes when the test is written before the code. Moreover, testing depends on the project process and associated stakeholders. Large firms, most especially IT industry, have team tasked with evaluating the generated software in light of the supplied requirements. Furthermore, developers perform unit testing, which is a type of testing. Some example are: 1. Test manager, which manage and control a software test project as well as supervise test engineers and define and specify a test plan. 2. Software test group and testers, which define test cases, write test specifications, run tests. 3. Independent test group, which is an independent test organization that also tests software. There are benefits from being an independent tester group, like for example, an independent tester can repeatedly find out more, other and different defects than a tester working within a programming team or a tester who is by profession a programmer. An independent test group often has a separate budget, which helps ensure the proper level of money is spent on tester training tools, test equipment and etc. Aside from benefits, there are also risks from being an independent test group, like there is a possibility that testers and the test team can get isolated. This can take the form of interpersonal isolation from the programmers, the designers, and the project team itself, or IT can take form of isolation from the broader view of quality and business objectives, for example, obsessive focus on defects, often accompanied by a refusal to accept business prioritization of defects, as well as lack of identification with and support for the project goals, spontaneous blame festivals and political backstabbing. 4. Development engineers, which only perform unit tests and integration test. And lastly, quality assurance group and engineers that perform system testing and also define software testing standards and quality control process. They are just some who does software testing. Why is testing important? Software testing is important because if there are any bugs or errors in the software, it can be identified early and can be solved before delivery of the software product. Properly tested software products ensures reliability, security and high performance, which further results in time saving, cost effectiveness and customer satisfaction. Testing is necessary because software bugs could be expensive or even dangerous. Software bugs can potentially cause monetary and human loss, and history is full of such examples. In April 2015, Bloomberg Terminal in London crashed due to software glitch affected more than 300,000 traders on financial markets. IT forced the government to postpone a £3 billion debt sale. Nissan cars recalled over 1 million cars from the market due to software failure in airbag sensory detectors. There has been reported 2 accidents due to software failure. Starbucks was forced to close about 60% of stores in the US and Canada due to software failure in its POS system. At one point, the store served coffee for free as they were unable to process the transaction. China Airlines Airbus A300 crashed due to a software bug on April 26, 1994, killing 264 innocents' life. Sumo, Amazon's third-party retailer, saw their product price is reduced to 1p due to software glitch. They were left with heavy losses. Vulnerability in Windows 10. This bug enables users to escape from security sandboxes through a flaw in the Win32k system. In 2015, fighter plane F-35 fell victim to a software bug, making IT unable to detect targets correctly. There are lots of happenings like this in the past as well as today. That is why it is really important. It is really important that you achieve optimum test result while conducting software testing without deviating from the goal. But how you determine that you are following the right strategy for testing? For that, according to International Software Testing Qualification Board, there are 7 principles that should be considered when developing the testing strategy for a software product. 1. Testing shows presence of defects. Testing principle states that testing talks about the presence of defects, i.e. software testing reduces the probability of undiscovered defects remaining in the software, but even if no defects are found, it is not a proof of correctness. 2. Exhaustive testing is impossible. Yes, exhaustive testing is not possible. Instead, we need the optimal amount of testing based on the risk assessment of the application. It is the process of testing the functionality of the software in all possible inputs, valid or invalid, and preconditions is known as exhaustive testing. 3. Early testing. To find the defect in the software, early test activity shall be started. The defect detected in the early phases of SDLC will be very less expensive. For better performance of software testing will start at the initial phase, i.e. testing will perform at the requirement analysis. 4. Defect clustering. In a project, a small number of the module can contain most of the defects. Pareto principle to software testing state that 80% of software defect comes from 20% of modules. 5. Pesticide paradox. Repeating the same test cases, again and again, will not find new bugs. So it is necessary to review the test cases and add or update test cases to find new bugs. 6. Testing is context dependent. The testing approach depends on the context of the software developed. Different types of software need to perform different types of testing. For example, the testing of the e-commerce site is different from the testing of the Android application. 7. Absence of errors fallacy. If a built software is 99% bug-free but IT does not follow the user requirement, then it is unusable. It is not only necessary that software is 99% bug-free, but it is also mandatory to fulfill all the customer requirements. Above all, remember that test principle will help you create an effective test strategy and draft error-catching test cases. There are 5 phases of the fundamental test process. 1. Test planning and control. The initial stage of the process, test planning and control, is a significant part of software testing lifecycle, STLC, where test manager or test lead determines the efforts and cost of the entire project. Here the team works together to prepare test plans, define test objectives, and to build up a test strategy to effectively implement test plans at various levels of the software. 2. Analysis and design. After culmination of the planning stage, the team moves on to the analysis and design stage, wherein test cases are created with the assistance of the information and output provided from the previous stage, i.e. test planning and control. 3. Test implementation and execution. During this stage of testing, test scripts and procedures are outlined by integrating the test cases in a particular order, setting up testing environment and executing the test cases. 4. Evaluating exit criteria reporting. This phase involves evaluation of outcomes of the test implementation and execution stage, to further decide the ways of testing as well as its closure. Based on the risk assessment, exit criteria are prepared, which work as a metric to determine the amount of testing needed in the product or project. 5. Test closure. As the name suggests, test closure is the last stage of any testing process and is generally initiated after the delivery of the software product. However, this stage of testing can also be initiated because of various other reasons, like the termination of the testing process due to non-achievement of target, cancellation of the project, when product needs updates, among other things. Let us differentiate QA, QC and testing. QA or quality assurance is a management method that is defined as all those planned and systematic actions needed to provide adequate confidence that a product, service or result will satisfy given requirements for quality and be fit for use. QA includes activities that ensure the implementation of processes, procedures and standards in context to verification of developed software and intended requirements. QC or quality control is a process through which a business seeks to ensure that product quality is maintained or improved. Quality control requires the company to create an environment in which both management and employees strive for perfection. This is done by training personnel, creating benchmarks for product quality, and testing products to check for statistically significant variations. IT includes activities that ensure the verification of a developed software with respect to documented, or not in some cases, requirements. Testing a procedure for critical evaluation, a means of determining the preference, quality, or truth of something, an examination, or experiment. IT includes activities that ensure the identification of bugs/errors/defects in a software. Some of the other standards related to QA and testing processes are mentioned below. IEEE 829 Test Documentation. IEEE 830 A Guide for Developing System Requirements Specifications. IEEE 730 A Standard for Software Quality Assurance Plans. IEEE 1018 A Testing. IEEE 12207 A Standard for Software Life Cycle Processes and Life Cycle Data. ES 7925 A1 Vocabulary and Terms in Software Testing. ES 7925 A2 Software Component Testing Standard. There are two types of testing. 1. Manual testing includes a software manually, i.e., without using any automated tool or any script. IT requires a tester to play the role of an end user whereby they use most of the application's features to ensure correct behavior. Let's take a simple example to explain this. A developer has created a website and wants to test IT for functionality. In this case, the expected behavior is that the user must be able to enter the username and password and submit the credentials by clicking the login button. However, when the test is executed, the login button doesn't redirect the user to the home page. In such a case, the QA will report a bug to the developer. Manual testing plays a vital role in exploratory testing or in test cases that are executed once or twice. This helps QAs to discover bugs in the early stages of the development cycle. 2. Automation testing is a software testing technique that performs using special automated testing software tools to execute a test case suite. The automation testing software can also enter test data into the system under test, compare expected and actual results and generate detailed test reports. Software test automation demands considerable investments of money and resources. Test automation is the best way to increase the effectiveness, test coverage, and execution speed in software testing. The following tools can be used for automation testing. 1. HP Quick Test Professional. 2. Selenium. 3. IBM Rational Function Tester. 4. SOAP Test. 5. Test Complete. 6. Testing Anywhere. 7. WinRunner. 8. LoadRunner. 9. Visual Studio Test Professional. 10. WATIR. These tools is necessary because it is required to point out the defects and errors that were made during the development process. There are 3 types of testing. 1. White box testing. White box testing, also known as glass box or transparent testing, is an approach in which the QA is familiar with the internal code or structure of the application. It is primarily used for unit testing. White box testing also covers specific techniques like data flow testing, control flow testing, decision coverage, and path testing, and a few others. This includes unit testing, which involves verification of individual components or units of source code. A unit can be referred to as the smallest testable part of any software. While functional is a quality assurance process and a type of black box testing that bases its test cases on the specifications of the software component under test. 2. Black box testing is a test approach in which the QA doesn't have any knowledge about the underlying code or structure of the application. The QA interacts with the software application just like an end user to test its functional and non-functional behavior. This helps to discover some bugs typically overlooked in the earlier stages, which includes functional testing, integration testing, system testing, usability testing, compatibility testing, configuration testing, and concurrency testing. 3. Non-functional testing is the testing of a software application or system for its non-functional requirements, the way a system operates, rather than specific behaviors of that system. Non-functional testing includes security testing, automation testing, performance testing, load testing, stress testing, volume testing. Documentation testing includes the plans, results, and a testing system of a system or a system component. IT includes test case specifications, test plans, test procedures, test reports, and test logs. Test documentation includes all files that contain information on the testing team's strategy, progress, metrics, and achieved results. This section describes some of the commonly documented artifacts related to software testing, such as test plan, test scenario, test case, traceability matrix. Here are the skills that is required to become a software tester. A good software tester should have sharp analytical skills. A good software tester must have strong technical skills. A good software tester must have a good verbal and written communication skill. Testing at times could be a demanding job, especially during the release of code. To be a good software tester, you must have a great attitude. To excel in any profession or job, one must have a great degree of passion. Remuneration of software tester. Software salary tester in India has an average pay of Rs 310,575 per year, while in the United States software tester earns an average salary of $55,334 per year. Experiences strongly influence this job. Career path of tester. Any tester has many ways to grow throughout their career by starting as a trainee or junior. One can constantly grow and learn by obtaining new skills, taking on new responsibilities and facing challenges. In short, we all started from the bottom of our career, and IT takes courage, grit and perseverance to succeed. We all start from the lowest, and it is up to you on how you change your path. Scope of testing. Software testing professionals are in demand in any country, most especially and abroad.